So hi everybody, welcome to the first TSD meeting after this year's ONS. And thanks David for, well first of all I wanted to say, by the way, welcome David and Utah to the TSD. It's really good to have you guys, because you've been contributed, both of you, throughout the years anyway, so this is a really good addition to the TSD. And so I guess David, as an inaugural topic here, you're gonna walk us through some proposal for process disaggregation for just long-term aspect of the evolution of the architecture. Is that right?
I wouldn't call it a proposal. I'd call it some talking points at this point.
That sounds good, and I think it's going to kind of dovetail to a little bit with what we talked about on Monday, which was the GRDC design. So, well, with that, why don't you just take it and lead up to this.
Thank you very much. So I did create this very quickly, a little wiki page on process disaggregation. And briefly, when I say process disaggregation, what I'm really talking about is, does it make sense to take ONOS as it is and break it up so that there are different processes that make up the system, as opposed to having everything in one JVM today? And I understand there's multiple JVMs when you go to clustering, but I'm talking about, you know, in terms of even a single instance of ONOS as a product, you know, splitting that up into separate processes. Further, when I often talk about processes, at least for me personally, I immediately associate a container to a process. So it's almost a direct line. You know, process disaggregation really means splitting ONOS up into multiple containers, cooperating containers, into a microservice architecture. You could almost read it as that. And so that's kind of how I describe that in here. You know, just as people go through it, parse process almost as container in this write-up.
Well, I'm just gonna sort of preempt a point here, because if Bob is online, he'll probably would have something to say here. I would try not to conflate the process and container. I would just simply say split into multiple processes, and whether the processes stay just processes, or whether each of them will be encapsulated by, or at least some of them will be encapsulated by a container. I think that's a secondary thing. So just to sort of preempt any contentious points here, I would just suggest we stick to the process.
Fair enough, fair enough. In particular, when I look at ONOS, I really divide it into two groupings myself, and often it's the apps on top of ONOS, and I see those apps as potentially separate processes. And then I see the part of ONOS which actually communicates with and pushes flows down primarily to devices. And so when I look at process disaggregation, those are very, to me at least, a nice breaking point or borderline boundary between these two. Mostly when I look at the apps, draws my thinking this way, because a lot of the apps don't have what I call a reactive aspect to it. So when you look at process disaggregation, you have to look at, okay, what's the latency issues? What are the bandwidth issues for communication between these processes? And in terms of a lot of the apps, they're provisioning flows. In other words, there's some configuration that's managed. Based on changes to that configuration, they calculate a list of flows to push down to a list of devices, and then those flows are pushed. And there's not a lot of reactiveness. Some applications have reactiveness. So when you look at process disaggregation, you have to say, okay, can we meet latency and throughput issues and have inter-process communication to have those reactive processes? Or does that mean sometimes apps make logical sense as a separate process? Sometimes apps make logical sense as part of as a separate process and part in process, or different combinations thereof. And so that's kind of the way I think. Now, why disaggregation? Why split this up? One reason I often give is you can scale these things independently. So if I have an app that takes a lot of processing power and 10 apps that don't, I can scale those independently. I get that capability. It also gives me a better failure boundary, which means if an app fails, I can kick it and restart it. It has limited impact on the rest of the system because it's a separate process. I can also start writing my apps in multiple languages. I can pick the language best fit for the need because I'm not language bound as if everything in one process. And these are kind of the reasons I give a lot of the time. Now,
Yeah,
a lot of these things can be accomplished in the existing architecture. I'm not going to disagree, right? I could write a little app, in-process app that calls out to an extra process app, or I could write my app separately that calls the REST API. I'm just wondering if there's some formalization around this that could help. There was a question I didn't.
Right. Well, I was also going to point out, I mean, you have also better isolation, right? And resource isolation, not just failure, but also resource consumption isolation between apps if you rely on the existing mechanism of process isolation to effectively provide a barrier, because those barriers today are hard to achieve within a space of a single JVM process.
Right. I mean, I understand CRAF and OSGI does try to provide some isolation.
Yeah, but not sufficient, right? Not nearly at the level that you get with the process.
Right. It also brings some other interesting aspects. Could I start creating test harnesses around my app so that I can kind of develop these in isolation and run them through tests, externally before I even put it in a controller. You could do some interesting things there, I think, as well. And then you look at how does this scale up? Well, let me actually back up. I look at vendor adaption layers. Could each of those be a separate process? So depending on which vendor switches I have or which protocols I'm using, you can deploy different processes to support all those. And then the flow or flow API, which I have in this diagram here, really becomes take the API above, translate it to kind of the internal system API, and pass it down to the correct handler or adapter down to the device. And you get kind of that flow through there. And again, it becomes I deploy what I need to deploy, I scale how I need to deploy it, and I have that isolation. I did draw storage as a separate process here as well. And I think there's some interesting discussions that can be had around that in terms of how do we cache things out to a separate storage process? How's that work in the cluster? Again, I haven't thought all these issues through, and I think needs to be just some discussion about that. But it does say now we have a storage API potentially. Well, we have to if we have a separate process. And does that say, okay, if I want to use kind of what we have today, there's a way to do that. But if I want to use an external process, maybe I have a customer who says you must store everything in Oracle. And yes, there's some performance and other limitations around that. I get that, but maybe there's a way to bridge that to there. And then when we talk about scaling up, does this then just become essentially redeploying the set of containers over and over and over? Or does it say, look, when I scale up, I still have a storage container that I deploy close to the switches, but that storage container, as defined by complying with the storage interface, now becomes a cache. And so it's not the master storage unit, it's a cache. So that kind of unit can run independently if it loses connectivity to a peer or an upstream, which is the master storage. But the containers all work the same, right? The interfaces are all the same. And does it give us kind of different ways to deploy deploy the controller, different ways to experiment with how we're going to scale this up into a distributed environment? Is it hierarchical? Is it a star peer-based kind of structure? How do we want to scale this up? And it gives us a way to play with that, I think, a little bit, easier because we have those kind of separations of concerns based on interfaces. Again, I want to emphasize that, you could do this with existing architecture. As Thomas pointed out, it gives, the microservice architecture gives you better isolation. And that's one reason I push for it, and I have pushed for a while. I agree, and I've talked to Thomas about this in the past. The minute you go to microservice architecture, it adds complexity to the solution, primarily around deployment. How do we get up and going? I think as we look at container management systems, Docker Swarm, Kubernetes, Mesosphere, whatever someone wants to deploy, this helps us in terms of deployment complexity because they all kind of have structures they provide that says, hey, you can set up what your set of services look like and how they interconnect. Gives you the service discovery capability, that type of thing. And so it gives you kind of a one command way to set up this microservice solution. And so it eases that, at least some of the deployment complexity. There's other things we'll have to consider going forward in terms of troubleshooting, logging, all those complexities, because now you have multiple processes, each kind of spewing their own log data, whether that's over a message bus or just to standard out, so it's in the Docker log, or sorry, process log, standard out. And there are tools that can help around that. There are tools today that exist, third party, that could be leveraged for that. And in terms of even inside ON.Labs, through the Volta project, we've got some insight into what they're doing, and it might be useful to learn from that in terms of how they're managing that. And again, the Docker Compose stuff does imply a container as opposed to just a set of processes. And there is a difference there, right? If you say a process isn't a container, well then, yeah, you've got to set up all these processes. Init scripts, there are ways to manage that, I think. And I think it is in the best interest of ONOS to be able to say, look, if you want to run ONOS and you're just kind of experimenting, we need to get you up in 5 minutes. And so regardless of kind of that underlying architecture, we need to be able to support that kind of deployment. And I think that's important. Otherwise, if it's too hard to set up, people are going to walk away, to be honest. So that's kind of my 15-minute or 10-minute spiel on this. Again, I'm really just looking to start a conversation, and over some time period, and I don't have any boundaries on this really, seeing if this makes sense in terms of directionally for ONOS, and if so, how do we make these changes in that direction? For instance, apps like intent or the VNet stuff, does that make sense to pull that out as a separate process and have it pushing down, right? And is there ways that we can experiment down this direction?
Sure. I mean, there's definitely a number of benefits, right? But as you mentioned, complexity is one of the caveats. There's probably other caveats that we at least ought to acknowledge. We don't necessarily need to have a solution for them right now, but at least, for example, the state management. To me, it's a little bit more than just the storage, in the sense that you need to worry about coherency of the state.
Yep.
The fast memory, right? The storage, to me, I look at kind of really just as a persistence, but the distribution of the information. If you now have the state, let's say they give the authority for the state, let's say for the topology graph, it's now resides, let's say, with some sort of a loose cluster of components, but then the applications that need to act on the network still, for some reason, let's say, need to have low-level access to the graph, but now they're off-platform. How do those applications now get access, high-performance access to that state, and also some level of guarantee about the state being reasonably up to date? And so some of those topics will probably also have to be discussed and have at least some plan for how to overcome those.
Yep, absolutely agree.
So David and Tom, this is Tom Tofig, and so I just joined because I thought this was an interesting topic. One comment is I really like what I heard from David. I mean, the concept of being able to have distributed processes that you can spin off various containers and create inner working between processes, etc. And I guess one concern I have is can garbage collector be managed? Especially if you're looking at a very high performance millisecond level performance, so we can have predictability on some of the loops and all of that for M-Core. And number two comment is, can we maybe use the concept of OTP from Erlang, which is similar to what I think David described in terms of ability to spin off processes and have root processes for managing the worker processes, and you can have reliability and availability, etc. introduced? Can we maybe conceptually at least look at that, to see if we can meet some of the OTP claims?
Yeah, I'm a big fan of OTP and kind of the fast fail Erlang philosophy. So I think it would be good to look at those and say, okay, how can we accomplish some of these goals? And in terms of millisecond response and those other things, I mean, part of this I think is we have to look at each component and say what language, and I guess that's the best way to put it, what language best fits the implementation of this process. And so in terms of any given process performance or capability, we can make those choices independently. In a real world example, I was at some place recently where we needed to do a raw packet out from ONOS, and ONOS couldn't do that, right? Because it uses Java layer 3. You'd have to go, to a native interface to do that. And there, yes, you can write a library in Java that goes talks a native interface, but some of that says, wow, it'd be really nice if in terms of the packet out capability, we could somehow use a language where that is a primary construct or a primary ability, so that you wouldn't have to. In this case, we created a OVS switch and kind of passed it through that to packet out it. It'd be nice to be able to do that, get those millisecond response times, or if there's some piece of code that is highly repetitive and a garbage collection mechanism may not be the best solution for that piece of code. Maybe you write that in C or C++ and memory manage that a little bit differently, right? And there's other places where Java's the perfect language, or Scala or whatever, and it allows you to customize those, I think, a little bit. I hope where it makes sense we could do that, right? You don't want to pick a language, I don't want to write this in Go just because I love Go. I want to write it in Go because that makes sense for this component.
Exactly. No, I think, as you said, we need to somehow, especially when it gets to millisecond performance requirements, we need to be able to disable the garbage collector or something, so we don't run into, those kind of, I'm not sure if we can do that in Java, honestly, but I think I'm all with it, or I'm all for it.
Sure. I definitely get the benefit of using different, using the appropriate language, the process isolation, better failure domains. There's definitely a number of benefits, right? Of course, this has to be coupled with a reasonable sort of API mechanism, such as GRDC or something like that, that will at least not get in the way, like, for example, REST, right? REST is good for certain things, but it may not be suitable for high frequency and high granularity operations.
I absolutely agree. And again, this may be someplace we can learn from the experience of Volta and contribute back if it needs changes there as well, where they have kind of the base level API is gRPC, and then they have a container that provides REST above that, essentially a mapping down through the gRPC stuff, and using essentially protobuf as their IDLE language to generate all that.
Right. Well, so to me, clearly, if you were to, let's say, paint it as a long-term goal, right? And this is exactly what I was saying in the meeting on Monday, in GRDC meeting on Monday, right? That I'm definitely willing to paint that, kind of put a pin in this as a place on a map where we should try to get to. The question is, how do we get there without with the least amount, or at least fewer instances of discontinuity along the way? Because clearly, right now we have it based on symmetric architecture, where the cluster is fully identical from node to node. It's all in a single process, and we have some established APIs and set of features built around those APIs. And so the key in here will be, for me at least, is how to evolve towards the long-term goal from where we are now in the most optimal way. And what the most optimal is, one big discontinuity or potentially a series of smaller discontinuities, or perhaps I'm wrong, maybe there is no discontinuities that we need to suffer. I don't know. To me, that would be the biggest dilemma of how to get there.
Yeah, I agree. And in terms of like the gRPC interface, could we slide a gRPC interface in there and keep REST compatibility somehow, right? In terms of that other issue, the other meeting that happened Monday. In terms of an app, could we find an app that is not reactive, really is kind of a provisioning app, and could that be rewritten as a separate process using the existing REST API even? Because the frequency of calls is such that it allows that. And that might be a place to start branching off some of this and just, testing the waters, seeing how it works, seeing where there are flaws.
I think that kind of use case exists in the hierarchical control kind of thing to manage the geographically distributed situation where the top higher level control and will not going to be probably not going to be reacting to the actual packet and so on, but we'll want to see the sort of entire view and start provisioning the path, and the actual handling of the packet and so on is going to be handled by the local controller. And that could be today's ONOS itself, and build something hierarchy of control over it. Then eventually maybe could dissect existing ONOS into smaller process in the future or something.
Yeah, that's a good idea, right? For sure.
Yeah,
I mean,
so
that would be a starting point. So rather than basically what that would involve, rather than focusing on making ONOS, single ONOS cluster capable of scaling over larger and larger environments, would be to see if we can figure out how to build it in a manner that would basically where the same control domain would be controlled through a hierarchy of controllers.
And even if you just start with kind of a viewer, which is, look, I have these multiple clusters of ONOS, and even if I can't do control down through this other Uber ONOS, if you will, I can actually get at least a global view, right?
Right, for sure. Yeah, and I think I mean, you made David, you made the point repeatedly about finding something that doesn't require reactive control. I mean, I wouldn't necessarily even get hung up on this, right? Because even though it's not strictly something like reactive forwarding, I mean, if it's something that does intent-based programming, or even it's a flow-based programming entirely proactively, it may still be something that's in need of low latency and high throughput, of operations. Something that can sustain those properties of communication. And so I think regardless of whether we do that, we should make sure that whatever it is that we choose for API, in my view, there's really just one candidate really, and that's the gRPC, that it meets those goals and it's constructed in a way to not to compromise those qualities.
Yep, no, I agree. And actually, as I was thinking through this, I was thinking, even for kind of the high volume reactive forwarding that required, is there a way to say, look, rather than always punt that up to the application, whether that's internal process or external process, is there a way that you can specify, can we create a language, for lack of a better term, that says, this is how I want the controller to handle those high volume, reactive forwarding commands?
We already have a language for that, right? It's P4.
Oh, right. Right. And so, it becomes that my app then, which is external to the controller, says, look, here's the flows I want to push down, and by the way, here's the P4 I want to push down. Right? And then it's completely out of the picture at some level, except reacting to the kind of lower latency events, such as, by the way, this went down, what do you want to do, right? Reprogram it or whatever.
Right. No, I like the idea of potentially structuring this, setting up the hierarchical federation as an exercise to accomplish this at the first level. And clearly gRPC, this whole external, at least gRPC as an external mechanism also kind of plays into that, right? Those could be the two pieces of puzzle. One provides kind of the use case, and one provides the sort of means to wire up together basically a sort of logically unified control realm, but one that's built from hierarchy of different pieces.
Yeah.
That's probably
how's best to carry this forward, I guess, becomes the next question, right? What's the best way to go forward from here?
Oh, I mean, that's kind of what I was. I mean, I really like Gita's idea, and so I'm thinking that really ought to. I mean, unless somebody else has some even kind of, I guess, lower hanging fruit, I think that probably ought to be put up there, right? So we're doing gRPC already, at least as a incubation exercise right now, and then we just need to make sure that when we, you know, as we promote, or as we're talking about, let's say for L release planning, if we can find a use case for or justification for doing the hierarchical federation, then we could structure it as an exercise in disaggregating or at least proving that this disaggregation can be done at least at a course level first.
Yep. All right, so that says somewhere there has to be a project proposal for dealing with this hierarchical disaggregation, for lack of a better term, and push that forward.
Yeah, we should. Yeah, exactly. Right. I mean, the thing, how to clearly, this has to be done against the other priorities that exist in the roadmap, and I'm sure as with every cycle there will be slight reshuffling of those priorities as we, retrospectives on releases and conferences and meetings with our partners.
Yep,
So
understood.
I think we should use that as an opportunity. I would suggest that the next release, next release planning cycle, we give that a serious thought and see if you can find sort of a landing spot for the hierarchical federation with gRPC as a proving point for this.
Okay. So, and I guess does that become two project proposals? One is kind of the gRPC mechanism, and then one is the hierarchical structure on top of it, versus one thing that kind of combines them all.
Yeah, I guess I'm not too concerned about drawing where the boundary between those two things lie, because I guess I view this more of this continuous spectrum. But I mean, it may be possible we need to do it as two different things, but I mean, we already have scheduled the code-based disaggregation, which is admittedly a different thing, but they may be related, right? Because the code-based disaggregation may actually end up mirroring somewhat, or at least indicating where good process boundaries might lie as well. Too. I mean, I'm not saying that they're strongly correlated, but there will be some correlation. And
yeah, I would agree.
But I think also in the meantime, we probably ought to give some thoughts and explore some models about some of the other issues. The complexity I'm actually less worried about, even though I completely agree that it is something that will have to be solved so that people can get up in no time. But I think this is, like you said, this is where we can rely on tools or put together some tools or whatever to manage that. I'm not so much worried about that one. What I'm more worried about is our approach, have a story for how the state is going to be distributed across and preserved across sort of this now more fractured landscape, right? Where you have applications may have their own state. Today, the on-platform applications or ONOS extensions, we offer to manage their state by giving them the primitives to build stores and stuff like that, so they can manage it how they need to. I mean, that has some nice properties, right? But it slices things sort of in these columns, vertical columns, rather than these sort of horizontal rows.
Well, and there's nothing to say that we couldn't develop a library for whatever, we have a Java language library for helping with those application storage concepts. That could still be there. So if you decided to write your app process in Java, you could still use the ONOS distributed store library, for lack of a better way of expressing it. And you could use kind of that standard storage mechanism, and we could write adapters for other languages as the need arose if we wanted to.
Yeah, and it's possible that the storage itself right here could be just basically not like a low level. It would be basically just a place to keep the central information about this, like the network state, whatever that may be, flows and everything else, and it's actually as remote as everything else, right?
Yeah.
That applications really, everything that the applications have or the adapters have are effectively just transient copies.
And I think, yeah, and that becomes more interesting, I think, as we scale up, right? Where, how do we split data? Where's the mastership and where's the cache? And I absolutely think those need to be discussed and thought through, because it'd be nice to say, look, this node is toast. Let's just kill it, back to OTP, kill it and restart it, and it can get what state it needs back from somewhere else.
Yeah. Yeah. So I mean, clearly, so we ought to at least give thoughts to some of these topics, because there's no reason we need to wait, for example, before because clearly this has to be thought through, right, and at least evaluated based on caveats and benefits of different approaches.
Yes.
And so that when at least deal with that as a sort of at least as a background task as we work on stuff, and so that way when we're ready to move forward, we at least have some sort of a approach in mind.
Yeah, absolutely agree.
David, is there a success criteria that we can put up for this re-architecting, in terms of delay budgets and etc. for various core platforms?
I mean, buying new hardware.
Okay, that's a good one.
Is that what you? I guess I'm not quite sure what the question means.
No. The success criteria is that we should be able to handle certain delay budgets for. Is it like 5 millisecond, updates, or
Okay.
or
There aren't. Yeah, there aren't criteria today. There absolutely need to be, right? And again, how you split applications and both the interfaces between them, absolutely have to take into consideration kind of the latency and throughput and all those issues. What is my delay? Absolutely have to take care of that. This is why when you talk about, rather than code reactive forwarding, can we push it down by P4 and the P4 processor happens? Does that mean they have lesser latency? Maybe it does, right? We don't necessarily have to pass everything up to the application layer anymore. We need to set those. Those are going to be set things by M chord, for instance, by R chord, by E chord. They're going to have to set what restrictions they have, what requirements they have, and that'll have to feed into this and be tested.
Okay, maybe I'll take an action item to work with OS and others to see if we can come up with a few benchmark, requirements for M chord. Okay.
And I just mentioned the chord applications or chord scenarios. There are others as well. Just using SDN as a controller completely outside of chord, people are going to have requirements.
I mean, so you can take care of some of these things, like you indicated, by pushing them closer to the data plane or on the data plane entirely. But then there is also cases where that might not necessarily be appropriate or possible. When you need to deal with large amounts of data, that the control data, or at least sensory data, based on which you then need to make decisions, and how to make sure that that state gets preserved, replicated appropriately, and accessible with reasonable latencies for processing. And I suppose that's where we can probably lean on more on what the cloud does today with big data. Yeah, and this is really interesting, and definitely to me it would represent at least I don't imagine it accomplish. I don't imagine we could accomplish it without some level of discontinuity, but but that's fine. I'm not at all saying that that's not something that we ought not to think about, for sure. we need to continue to evolve, right?
All right. Well, thanks for the time. Again, that's kind of what I want to start, is that conversation, figure out where we want to go. So very much appreciate it.
Cool. Well, thanks for putting it together. Does anybody from Menlo Park have any additions, comments?
Sort of minor logistical things, but I was wondering where this David's page should whether live in this ONOS steering team space, or should it be moved to ONOS space on the wiki?
Wait, I'm not sure I understood the question correctly. What we talking about, the wiki page that David?
Yeah, it's now created under the ONOS steering team space in this Wiki ONOS project, which is not going to be searchable if you're looking from the ONOS top page. So I was wondering maybe this page should be moved to the ONOS.
Oh yeah. Sure. Yeah, I'm perfectly fine with that. Yep.
So if someone can point me at the parent page, I can move it, or I guess it's a wiki, anybody can.
Yeah, I'm not sure where it should sit, but yeah, at some point, yeah, I think we should move it to ONOS space somehow. Anyway.
Okay, I'll try to figure a place off the main page.
Yeah, what we probably ought to do, just like we have the process, so code disaggregation, we probably ought to put it on the roadmap, at least so that it's so that it shows up, and we can figure out where its position would be as we do the planning for L release. That's something Ian can probably do, right?
Yeah, I can add it.
Thank you. At least that way it's on at least it's visible.
Yep, and it aligns with some of the things Ogaz has been talking about regarding MCORD. So I think once we look at those use cases, this will help help us determine the priority.
Exactly. Yep. Well, that's great. So if there's no other comments or additions, thanks a lot, David. And we'll see everybody next week.
Bye.
Bye-bye.
Thanks, David.